Let's look at section 5.4, polygons and angles. First of all, we need to know what a polygon is. A polygon is a simple closed figure formed by 3 or more line segments, and the segments are only going to intersect end points. Sounds really difficult, but we know lots of polygons. We know triangles and quadrilaterals, and we know lots of other ones, pentagon, hexagon, octagon, decagon, several different ones, and we'll learn more as we go through this lesson. Let's start with our key concept of the interior angle sum of a polygon. All right, the sum of the measures of the interior angles of a polygon is n minus 2 times 180, where n equal the number of sides of the polygon. So the actual formula then is S equals n minus 2 times 180. So the sum of the interior angles equals n minus 2 times 180. Now we already talked about in section 5.3 the sum of the interior angles of a triangle, and that would work here if we wanted to plug a 3 in for the number of sides of a triangle. This 2 is 1. 1 times 180 is 180. So we're going to use this for different types of polygons. You can use the sum of the angle measures of a triangle to find the sum of the interior angle measures of various polygons. A polygon that is equilateral, meaning that all sides are the same length, and equiangular, meaning that all angles have the same measure, is called a regular polygon. And this is the type of polygon that we're going to be working with when discussing these concepts today. So let's just go back with our highlighter. And this is something that's important that we're going to need to know. We'll have to remember that formula. And remember that equilateral means all sides are the same length. Equiangular means that all angles are the same measure. And when they are both, it is called a regular polygon. All right, let's take a look at the next page. The next page we have a key concept. We have a picture or a table here that shows the number of sides, in this case 3. Anytime there are 3 sides, we know it's going to be a triangle. The number of triangles involved is 1. And the sum of the angle measures would be 1 times 180 equals 180 degrees, because n minus 2 times 180, 3 minus 2 times 180 is 1 times 180. If we have the number of sides 4, we know it's going to be a quadrilateral. We can draw a line in a quadrilateral and divide it into 2 triangles. Doesn't matter which quadrilateral you have, you can always do that. So the number of triangles would be 2. So n minus 2 times 180, 4 minus 2 is 2, times 180 equals 360. So we know that the sum of the angle measures of a quadrilateral are going to be 360 degrees. If there are 5 sides, we could divide it into 3 different triangles. 5 minus 3, 5 minus 2, so n minus 2 times 180, 5 minus 2 times 180, 3 times 180 is 540 degrees. If we have 6 sides, we can actually draw 3 different lines in here and divide it into 4 triangles. So n minus 2 times 180, 6 minus 2 times 180, 4 times 180 is 720 degrees. It's a good idea to memorize those. It makes it a little bit easier on you if you know that a 3-sided figure is 180 degree sum interior angles, A four-sided has 360 degrees as a sum for its interior angles. A five-sided figure has 540 degrees as a sum for its interior angles. And a six-sided figure has 720 degrees for the sum of its interior angles. But if you don't memorize it, if you know the formula to figure it out, you can always do that even if you were to forget. Let's look at the example. It says find the sum of the measures of the interior angles of a decagon. Well, the first thing we need to know is what deca means. And if you think about the word decade, decade means 10 years, deca means 10, so we have a 10-sided figure. So we'll write our formula. We'll substitute in 10 for the number of sides. Ten minus 2 is 8. And when we multiply 8 times 180, and you will be using your calculator for these just to make calculations much simpler, we get 1,440 degrees. So we know that the sum of the measures of the interior angles of a decagon are 1,440 degrees. Doesn't matter what the decagon looks like, doesn't matter if it's regular or not, if we add up the sum of all the angles, they're going to equal 1,440 degrees. So for practice, take a minute and pause the video and think through, first of all, what octa means. How many sides does an octagon have? Use your formula, S equals n minus 2 times 180, and figure out the sum of the interior angle measures of an octagon. When you're finished, come back and we'll complete the lesson. Okay, hopefully you were able to figure out the sum of the interior angle measures of an octagon. Bring that to class with you tomorrow and we'll go through it and make sure you understood it. But let's look at the next key concept. Now in this key concept, we are definitely going to be using regular figures or regular polygons, because the only way we can determine the measure of one interior angle is to know that it is regular. So we're this time looking for the measure of one interior angle, where last time we were looking for the sum of the measures of the interior angles. So we're going to take 2 steps to do this. In step 1, we're going to find the sum of the measures of the interior angles. And we already learned how to do that at the beginning of this lesson. Is S equals n minus 2 times 180. Okay, in this case, they want us to find the measure of one interior angle of a regular hexagon. Regular meaning sides and angles are all equal. Hexagon, if you think about hexagon, it means 6-sided. So we're going to take in our formula, put a 2 in for n, and when we multiply 4 times 180, we're going to get 720 degrees. All right, so first thing we do is find the sum of the measures of the interior angles using our formula. So step 1, and this is going to work for all the problems, so let's just highlight the part that we're going to use for all problems. And then in this case, we were looking for a regular hexagon, so we substituted in 6, and we got our answer of 720 degrees. Step 2. Now, this told me the measure of all 6 angles together. Step 2, we want to find one angle. So we're going to divide the sum of the measures of the interior angles the number of interior angles. To find one angle. So in this case, we had 720 We know that a hexagon has 6 sides, so 720 divided by 6. And so we're going to end up with 120 degrees as our answer. But for all the problems, we would take that sum that we got from step 1 and divide it by the number of interior angles or sides of the regular polygon. So the sum is what we got here. So we're just going to divide the sum, that's 720 in this case, of the measures of the interior angles by the number of interior angles to find one angle. Let's look at another example to see if it helps us. In this example, we're going to find the measure of one interior angle of a regular octagon. All right, so regular octagon, hopefully you decided in your last practice problem that octa means 8, so we have 8 sides. So step 1, we'll take S equals n minus 2 times 180. S equals 8 minus 2 times 180 because we have 8 sides. S equals 6 times 180. When we use the calculator, we should get S equals 1080 degrees. But that's all 8 of the angles. We need to know 1. So we're going to take step 2. We're going to take our sum of 1080 and divide it by the number of sides or number of angles, which is 8. And we get 135 degrees. Okay, so take a minute and pause the video, and I want you to go ahead and try to figure out the sum of one interior angle of a regular 20gon. So this time they've told you the number of sides. It's a 20gon. Use your 2 steps and figure out the answer, and then come back and we'll finish the lesson. Okay, now that you've had time to complete that practice problem, let's finish up with our last key concept. This time we're going to talk about the exterior angles of a polygon. We've talked about the exterior angles of a triangle, and now we're going to talk about the exterior angles of all polygons. So our key concept is that in a polygon, the sum of the measures of the exterior angles one at each vertex is 360 degrees. So let's draw a little picture. So what this is saying is that all of them are going to be 360 degrees, but let's draw a picture. You might want to wait until I've got mine drawn before you try to draw this. It's not difficult, but it does take a little bit here. All right. And as always, I'm going to make a little mistake here, so let me fix it. Like I said, wait until I'm finished. Sometimes it will help so that you don't make the same mistake that I do. All right. So we have angle 1, exterior, 2 exterior, 3 exterior, 4 exterior, and 5 exterior. This is a 5-sided figure, 5 exterior angles at each vertex, so we have 5 exterior angles. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 equals 360 degrees. If this had been a 6-sided figure with 6 exterior angles, it still would have equaled 360 degrees. 3-sided figure with 3 exterior angles, 360 degrees. So regardless of the number of sides in a polygon, the sum of the exterior angle measures is equal to 360 degrees. Doesn't matter how many sides, it's always the case. So there's no work to do. Let's look at an example. Find the measure of an exterior angle in a regular hexagon. So we're wanting one exterior angle. So we know that a hexagon has 6 sides, and we know that the measure of the exterior angles is 360. So let x equal the measure of each exterior angle. All right, so we know that x is going to be the measure of each exterior angle. We know that there are 6 of them. So 6 times x equals 360. We'll divide both sides by 6 to undo the multiplication, and we get x equals 60 degrees. So one exterior angle of a regular hexagon is going to be 60 degrees. Take a minute, pause the video, and use your notes to see if you can figure out the measure of an exterior angle in a quadrilateral. First thing you need to do is figure out how many sides are in a quadrilateral. Remember that you're going to let x equal the measure of each exterior angle. So we're going to have blank x equals, we know it's 360. Plug in the number of sides from that quadrilateral and the number of angles from that quadrilateral, and then solve it. Bring that back with you tomorrow, and we'll go through it and make sure that you understood the concept.